Okay, why are we only 1, 2, 3, 4, 5? Got it. Okay, I'm giving you a couple of minutes. I'll ask a few questions. You have to answer those and then we'll move ahead. Okay. So take your time, do a quick brush up. And Nukul, Nandini, Subhajit, Mohammad Azam, I hope we are doing well. Subhajit, how are you?
I'm doing, sir. Okay, sir. What
Okay.
about you, sir?
I understand what okay means. I'm fine. I'm fine. All set to study today, Subhajit, in the present,
Yes, sir.
or are we
Yes,
distracted?
sir. Yes, sir. I'm set, sir. All set.
Nice, nice. Let's bring all our focus here and learn a few things. Hardly couple of hours. And yeah, Subhajit, nothing else. That's it. Mohammad Azam, finally, um, was it a big day? Are you free today to attend the class?
No, sir, I'm free.
Yes, sir, I'm free. Yes, good, good, good. Good to have you back. Nukul, any challenges? Nukul, I'm so sorry. Today I'm working on this, your computer number thing. You have to remind me after the lecture. Drop me multiple messages. I have put my reminders also to discuss with you. You also remind me. That's the only reason why we are unable to do it, because I just forget that one thing. Okay, so just
Affirm, sir.
remind me today. I'll give you a feedback on it, and tomorrow you start working on that. Okay,
Okay.
so that you
Okay.
don't have to do all the corrections. Nandini, how are you? Any challenges? All good? Please tell me.
I'm good, sir. No challenges.
Very nice. Why do I feel you're just woken up? Are you feeling sleepy, Nandini?
No, sir. I just woke up, but I'm not sleeping.
Good, good. You're fresh. That's nice. Good. Great. So, quick revision through your rigidity. Quick revision. I'll just add the lecture to our playlist and then I'll ask you questions and then we'll go ahead with our class. Today, I'm going to show you a basic flow chart of the various types of gyros. What are the different types of gyros? It will make your understanding with respect to technical terms related to gyroscope very easy. And we'll do all of it within the scope of our CPL syllabus only, will not be going out of it. Okay. There is more to learn, which you will learn a little bit more about ATPL and all. But that's it. We don't need more than what we are doing right now. Obviously, you can always read the textbook for further reading and extra material, like I always say. But these notes that you will be making today will be more than enough. One more thing, students, because we had to give a holiday for Eid, definitely. I think, no, we have another session on Friday, right? Yeah, yeah. We did not miss on navigation. We missed on regulations. Correct. No problem. This Friday will be completely done with gyros, and then I'll be giving you a task to do. And the only thing pending would be VOR, ADF related sums and numericals, which we'll be doing in peaceful manner. And that will sum up everything that you have to study for your CPL exams. Everything. It will cover 100% of your syllabus. So I'm expecting you all to score anywhere around 80, 85, 90 easily. So first question goes to Subhajit. Okay. Subhajit, how do you explain the application of a gyroscopic instrument in the cockpit?
So gyroscope is basically a gimbal-based equipment which senses the aircraft attitude and measures it with reference to the horizon of the aircraft or the natural horizon, and gives the input inside the cockpit that how so is the attitude of the aircraft, like whether it is rolling to the left or right or pitching up and down. So this is the basic principle and the usage of gyroscope according to me.
Okay, but that is okay. It's a valid answer. What you're describing is how uh, how the attitude horizon or attitude indicator or artificial horizon works. Yes, with reference to the horizon, we can measure certain attitude of the aircraft using gimbal system in a gyroscope. Correct? Those points are keywords, valid points. But what I'm seeking is, how is the entire gyroscopic unit or the instrument and the gimbal system put to use? I know the application, I know there's a gimbal system, fine. So that much is fine. Think about it, Subhujit. I want Nukul to take over the answer from you. The question still remains the same. Think what I would be asking about. The answer is correct, but remember, we are talking about the one thing that makes it possible. What is that one thing that makes it possible? Yes, Nukul. Subhujit, did you get the answer in your mind? What is that one thing that makes it possible?
Sir, I guess that's spinning rotor.
Yes, yes. Think about it. Nukul, Subhujit, keep thinking. Come to key points. Nukul, read your notes, everyone. You'll get the answer what I'm trying to hint at.
Because
Nukul,
of that spinning rotor. Okay, Nukul will take
Subhujit,
this.
stand by. Yes, you're getting there, Subhujit. Stand by. Nukul, your chance.
So you said that the application. So yes, we can identify our aircraft is rolling or banking or pitching up or pitching down. So, but I didn't understand what you're trying to get the answer from us.
So I'll rephrase the question again. How is a gyroscopic instrument used in the cockpit of the aircraft? On basis of what are the applications? On basis of what? What is this
And
gyroscope?
on the basis of rigidity and precision.
Exactly. Rigidity. Yes. Subhujit was getting there with the spinning rotor. Yes. Now that you focus on the question again, key point, rigidity. It is all about rigidity. Nandini, Mohammed Azam, rigidity. A spinning rotor has rigidity, and using this rigidity, that is the ability of the gyro or the rotor, however you call it, the ability of that gyro to maintain its axis of spin in a definite direction, in a fixed direction, fixed point in space, as long as the rotor rotates at a high RPM. Using that property, we have all applications in the aircraft instruments. All applications use rigidity. We need rigidity. Wherever there will be precession, it will be calculated precession to show us the bank angle and this angle and that angle if there exists. We need rigidity. That's it. Precession is opposite of rigidity. So jitna kam hoga utna acha hai. The lesser precession, the better it is. We need more rigidity. That's why we need that erection time initially, stabilizing time for gyro equipments. The gyro will not instantly turn on like a headlight or not a headlight, landing lights or any other lights. It takes time. Why? Because the rotor reaches a particular RPM. Why? Because to gain the rigidity to which the particular is tuned. Particular gyro is tuned, we can say tuned, or we can say designed to work for with respect to what. So now there are, how do I fix this axis of rotation into one direction? What are my references? Either I can take gravity as a reference. What? Gravity. Okay. If I use gravity as a reference to keep one axis rigid, that becomes Earth gyro. It's called Earth gyro. Okay. Are you following, students? And if I use a manual reference, like say I want to tie the, or let's say I want to use the gyro to show me something related to a particular axis. So I will make sure the axis of rotation of the gyro, the spinning axis, is tuned or aligned with either the longitudinal axis of the aircraft, the lateral axis of the aircraft, or the vertical axis of the aircraft. If I'm doing that, then the gyro is known as tied gyro. We are tying it down to something so that it comes back to its original rigid position, whatever reference we use. It could be longitudinal, lateral, or vertical. So it's called a tied gyro. So there are two types of gyros, an earth gyro and tied gyro. With respect to what do we have the rigid direction in space, either with the earth or with respect to any other reference. Simple. Are we following? any natural object, a cycle, a bicycle, like those things which require motion to create balance, they all are earth gyros. They are not tide gyros that we see. Cycles and bikes, they are earth gyros because they are aligned with the gravity only, nothing else. If you stop pedaling, you'll either topple this side or you'll either topple this side, right? You can either topple. So that is because of gravity you're toppling now. So that is earth gyro, simple as that. So today we are going to learn gyros, different types of gyros in these terms only. What are the types of gyros? Is it a earth gyro, tide gyro, displacement gyro, rate gyro? What are the different meanings? That's it. Okay. And Friday we'll be learning about all topics in detail, like what is DGI, and we'll write 10, 10 or 12 or 8 or 10, depending upon the topic. Important points based upon what type of gyro is this, what is the degree of freedom, how many motions of freedom do we have. It's a very closed, the scope of syllabus is very closed. Generally, students are very confused because they don't have clarity, but it's very closed as in there are only limited number of topics and limited number of things to study. So if you are confused, you clarify the confusion with me. Okay? As we proceed ahead. That sir, यहाँ पे मुझे confusion हो रहा है, ये समझ नहीं आ रहा. Okay. The next question I want to ask is, what is the formula for rigidity? Mohammad Azam.
R is equals to IR.
R is equal to?
IR. I is in a moment of inertia, where R is radius.
Mohammad Azam, careful. Check properly.
Not R is not radius. R is RPM, rate of RPM.
Yes. So why were you so confident in giving incorrect answer? Cross check.
Like
We need to
smaller,
make
I got radius in mindset.
Remember, I told you in class, that's the first confusion that can happen to everyone. Step by step, you have to study. Moment of inertia is dependent upon the mass and the radius. I, that's the formula for I, am into radius or diameter, whatever you want to use. Is that correct, Nukul? Check your notes. Subhajit, formula
Yes, sir.
for rigidity. So what are the factors, actual physical factors that are directly proportional to rigidity? So now you can describe, break down moment of inertia, break down RPM, if you have to break down, and explain everything. So moment of inertia, which is dependent upon the mass of the rotor and the radius of the rotor. In order to make sure the moment of inertia is more, the mass is concentrated towards the periphery, towards the rim. Remember that? Okay, good. Don't feel bad if you're giving incorrect answers or incomplete answers. This is practice. We are practicing. And remember, students, we have to be up to date. Okay, Mohammad Azam, we have to be completely clear and correct about our concepts. We cannot leave any room for error. 1 mark here and there, and we'll end up on 69. We don't want that. We need 70 or above, right? So we need everything 100%. Okay, very good. Okay, Nandini, the question is to you, and it's an obvious question. What is precession? And what's the formula for precession? Everybody, a question can come to you if Nandini is delaying the response or maybe wants some more time to study. So be prepared. What is precession and the formula for precession? Nandini, go ahead.
Precession is opposite to rigidity. That is, if the rigidity is more, the precision is less. And the precision acts to 90 degrees after the torque is applied. And it acts in the direction, the torque is acting in the direction of the spinning of the rotor. And the formula is precision is equal to torque upon rigidity. And rigidity can be I into R. That R is rotation per minute and I stands for inertia of movement.
Moment of inertia. Well said. Good answer. Still, I could not spot the keywords in your answer, maybe because you gave it in a very fast pace. Nandini, make sure you focus on keywords in your verbal answers, okay? It's a skill, it will be required to you in future, okay? Keywords. So, Precession, can you talk about precession again, just using keywords, Nandini, because I think I missed a few points.
Precision is opposite of rigidity. That if the rigidity of a gyroscope is high, it means its precise is less. And the precision acts 90 degrees to the torque after the rotation, and it acts in the direction of the rotor.
Yeah, precession acts 90 degrees in the direction of rotation after the torque is applied. Correct. Yeah, you can say that. Precession is the formula, correct? The formula, it's directly proportional to torque and inversely proportional to rigidity. It's not equal to, it's an inverse relationship. If you put an equal to in inverse relationships or direct relationships, you also include a constant. So you are not using constant in the formula. So you use the direct this symbol or inversely or directly proportional. Very good. Any confusion? Mohammad Azam, what happened? You're not smiling? Just because one partial right answer, you don't lose your hopes. Come on. You corrected it later on.
Answer, that's it.
You corrected it. It's learning experience, right? It tells us where we are, whether we are revising correctly or not. Or it just tells us that this topic we need to revise again properly.
No, sir, I was just recalling like precision, the whole thing. I was just recalling it.
Okay, so that was a serious face. Okay, fine. So you can always have a smiling serious face also. People will be like, sir, आप Colgate के लिए काम करते हो क्या? क्या ये smile चल रहा है आपका? Some people can say that, you know. I don't know. Good. Any questions? If you don't have questions and if you're still giving me partial answers, how will I move ahead? Think about it. Correct. Any questions? I'm giving you 5 more minutes. Go through your notes correctly, nicely, because what I'm going to show you now is going to be quick. It's not something where we have to spend a lot of time. A lot of time was required here. I'm giving you 5 more minutes. See if you have any questions. Nukul, can you describe precession, the process of precession? 5 steps of precession. 1, 2, 3, 4, 5. The diagram. Do we understand it? How is the torque applied? What is torque? Remember, the torque generally is applied on the axis of rotation. Through the axis, it acts either up or down on the rotor. And then on the rotor, it will affect the rotor 90 degrees in the direction of rotation. And then the axis will move from its fixed position. So it's axis that is moving from its fixed position. And that takes away the rigidity. This is the meaning of drift for a horizontal gyro. When a horizontal gyro becomes vertical, it topples. So a horizontal gyro can drift also and can topple also. While a vertical gyro can only topple, it cannot drift. So the shift in the gyro axis for a vertical gyro is called topple. And it happens because of precession. See, wordplay. We have to be clear about these terms. Nukul, simple? And a horizontal gyro definitely will drift because of precession or topple because of precession, depending upon the torque applied. Simple as that. Okay, your normal spinning top. Sorry, I could not get the demonstration aids today, but I'll get it Friday, our final session for gyros. That's when I'll show you. It is a vertical gyro and it is a earth gyro. The moment the RPM is reduced, it topples because of Earth's gravity. Simple. It's like that. Okay. Are we comfortable or are we still thinking gyro is something out of the box, something from an alien world? Even if you know half of it, don't think it is from an alien world. Think it's something very easy and I am understanding and I'll master it before my exams. Or whenever you want to master. I want you to master the concept. Forget the exams. Okay. Great. 3 more minutes. 3 more minutes. I'm going to go switch on a light and come back. Not 3, 2 more minutes. Any questions? Or else we'll start. Give me a second.
So will you be showing us an image of that Earth gyro versus tide gyro, both the images?
Actually, because Earth gyro is controlled by gravity, it falls under tide gyro only. It's just that the controlling factor is gravity. So I'm just making sure that Earth gyro and tide gyro are the same gyros. Earth gyro is tied by gravity and tide gyro related to whatever the application is. I'll show you all possible pictures or some that I'll be showing you the same set of pictures that we had seen in last class, but half of it were not applicable. And after that, in next session also, I'll show you more pictures which are not there in Oxford textbooks as and how need be. But remember, okay, Earth gyro is also tide gyro only, but tied to the gravity. I will explain. I'll explain the flow chart right now. Okay. Yeah. Um, Trying to visualize initially can be a challenge and a point of concern or a confusion to you as a student. So if that is happening, then you don't try to visualize. Just go with the theory. Okay. We'll keep the visualization part for the end when I just show you pictures and explain everything. Okay. If that happens, that sir, मैं theory तो समझ गया, practically नहीं समझ पा रही हूँ या समझ पा रहा हूँ. So I'll say, wait for that. I'll show you. Just make sure you remember the theory. Okay. Remember that, everyone. Great. Anything else? Feel free to ask. 1 more minute left. It's not like you cannot ask later, but I want to.
Question out of topic.
Sorry, say again.
I have a question out of topic.
Yeah, please go ahead.
DGC exam dates are out, right?
Correct.
It was mentioned like people who have applied for computer number also can apply.
Okay.
Can you help me out in that procedure?
But have you submitted your application for computer number?
Yeah, I have submitted the application, waiting for the email from their end.
So probably they will release it. Okay, probably they will release your computer number before the last date of application.
Okay.
So I think the last date of application is what, 12th or 14th? What is it? 16th?
20th, sir, I think. From 5th to 20th, I think. Just a second.
No, it's not 20th. Yeah. So you wait for it. You wait for their email. Either they will give you an acceptance email or a rejection email. That's what I feel. Otherwise, you cannot apply if you don't have a computer number. You try to log into your Pariksha portal and see if they are giving you an option to apply for the exam. That's the final thing you can try.
From 5th till 12th.
Because you will be applying for the exam. You'll apply for the exam through the portal only, pariksha.com. So if they are giving you the option when you do candidate login, then great. Then you do it. But I think they will issue your computer number before the final date is over. That's what they mean by that. Students who have applied for their computer number, you can also start preparing because we are releasing your computer number before the last date if you haven't yet already got it. That is what they could mean. Okay. Otherwise, if we don't have computer number, we cannot apply for exams. So just check on your Pariksha portal and see. Send me screenshots if you're confused. Okay. Log in with your email ID, phone. You know the process, right?
Roughly when it will be.
How you
like,
filled the form?
From 5 till 12, 5th May till 12th May. Approx exam will be in June.
No, they said end of May. End of May, they have said.
Okay.
Approx exam. Keep your video off and then try to talk.
I have an unstable internet, sir.
No problem. Keep the video off and talk. Yeah. You were saying, what is the last thing you said?
That approx exam date, sir, because exam date was not mentioned or like
approx, they have said end of May. So you can imagine end of May or first week of June.
Okay.
Subhojit, are you going to appear for this exam?
No, sir, not these exams because I think May last week I would be having some plans or some interviews.
Fine. It's okay. I just wanted to know. Good. I know your plan. Don't worry. I remember. Nukul, we are still pending for your computer number, so no issues. Nandini, I'm not sure where you stand on your computer number, Nandini. Let me know in case you are also appearing. I'm not sure. Nandini, you have not yet applied for your computer number, right?
No, sir, not yet.
It's fine. It's fine. So I think you'll be ready for the next attempt. I think you'll be ready for the next attempt. Good. Okay. Shraddha and Twarida, they are busy with their college semesters. So they are, missing classes. So I'll be teaching them again once they are free. So that's the situation. And I think everybody else is accounted for. I think Vivek Dhakar and the other guy they cleared, and Sankalp. And I don't think anybody else is left. I want you all to clear in your first attempt. So make sure you have that positive mindset, okay? And Nukul, just confirm with me, is it correct lecture number 48?
Sir.
Affirm, sir.
Is the connection error, students? Is there a lag, Nandini, Mohammad Azam, Subhajit, Nukul?
Negative, sir.
No, sir.
No, right? Fine. So make this flow chart. As I'm giving you the flow chart and the notes, I'll keep explaining also. It's very easy and it's very simple. So let's start. We're going to write down types of gyros. Okay. Firstly, the gyroscopes will be divided in two parts. The first classification is very simple classification. The first type of gyros are known as displacement gyros. And the second type of gyros are known as RATE, rate gyros. So now let's start talking about displacement gyros. What do displacement gyros do? Okay. Number one, displacement gyros, they measure angles. So if you have to measure pitch angle or bank angle, you need a displacement gyro. Pitch angle, bank angle, remember students, artificial horizon, pitch and bank, right? Simple. So any angle you want to measure, let's say you want to make measurements of any angular deviation, you will use displacement gyros. Okay. What are the possible angular measurements other than, what do we say, pitch and bank? Subhajit, what do you think would be other angular measurement required in aviation where we can use gyro?
Sir, yawing angle, but I don't think gyros would be used.
You are thinking in the right direction. You are thinking in the right direction, Subhajit. We don't say yawing angle. Yawing is what type of movement? Think about it. You're thinking in the right direction. I like that. Nukul, Nandini, Mohammad Azam. Nukul, what is the third angular measurement you could do apart from roll, bank, and pitch? What are the three types of gyros out of the 6 basic instruments? Yeah,
So
Nukul.
that
Wait, Subhajit,
slipping
wait.
and skidding.
No. You're right. Skipping and sliding. Slipping and skidding. I'm sorry, not skipping. But that is with the help of an inclinometer. Okay. That is in the gyro, but that doesn't have any gyro function. That is a different tube altogether. It's given to you in your bank angle, turn coordinator, that is. But no. You're right, but no. Yeah, Nukul, go ahead.
Sir, yaw.
Sorry, Nukul.
Yaw, sir, yaw.
No, your Subhajit already said, and the word is incorrect.
Yaw. Okay.
The word and term is incorrect, but your thinking is in the right direction. Yes, Nandini.
Heading and sorry,
Heading,
heading angle.
heading angle, heading. Yes, heading is also angular measurement, right? So in directions, come on, basics. Just today I was teaching it to first class, new batch. Yes, angular direction. Gyro compass, if you remember, DGI, directional gyro indicator. Yes. So covered, right? 3 gyros covered. Simple. Roll, pitch, and heading. And then the third is the turn only. So the turn indicator, turn coordinator generally involves the same bank angle only. Okay, good. Remember heading. So measures angles. What kind of angles? Let's write it down. Examples so that we have practical application. First application is pitch angle. Examples would be 5 degrees, 10 degrees, 15 degrees, 20 degrees. Generally, pitch angle is given up to 20 degrees only in the instrument. Okay. What is this pitch angle? If you're wondering what is this pitch angle, then I'll show you what is this pitch angle. This angle that you see between the longitudinal axis of the aircraft and the horizon. Okay. This theta is PITCH, pitch up angle in this example. Pitch angle is angle between longitudinal axis, in bracket you will write nose, and the horizontal. Now there are two types of horizontal. This is the side view horizontal, and there will be a front view horizontal also, which we refer as horizon. So in this example, this is pitch up angle. There could be pitch down angle also. Pitch up, pitch down. Okay, pitch angle. Second angular measurement would be angle of bank. Bank angle. In bracket, you will write roll. Definitely, it would be anywhere between, example, 0 degrees, 5 degrees, 10 degrees, up to 85 degrees is available. Now, what is this 85 degrees? How does this look like? It is simple. This is 0 degrees, bank angle. On the right, this is somewhere 45 degrees. This is 90 degrees, students. We will never fly like this. So we don't need 90-degree bank angle actually. But the instrument can give you up to 85-degree bank angle accurate values. Certain instruments, not all instruments. So this is the horizon related angle, bank angle. So you will make the aircraft from the front view. Okay. So front view aircraft will make like this. We'll show the aircraft and we'll show the window of the pilot like this. Like this. Okay. And then this is the tail. And then I'll make the horizon horizontal like this. Okay. And this is the aircraft wing. So this angle that you see over here, theta. This is your roll angle or a bank angle. Okay. So in this aircraft, because this aircraft is coming to you, it is rolling on the left side. If this aircraft was going into the page, then it would have been a right bank angle. So we follow the aircraft into the page or into the instrument always. So always when you are checking your instruments, gyro instruments, it will be the tail of the aircraft. Tail of the aircraft, like this. So now this is bank to the right or roll to the right. Okay. Bank angle to the right. Aircraft rear view. This is how you will be looking at the aircraft in all your instruments also. Bank angle to the right. Okay. The third angular measurement that you will get with the help of displacement gyros, you need displacement gyros. Basically, there will be one rigid axis which will get displaced with respect to the motion of the aircraft. So how do they work actually? In straight and level flight, they will show you straight and level indication. They will show you good amount of rigidity. The moment the aircraft moves like this or like this, you can say the rigidity is maintained and the frame of the gimbal is moving, and the frame along with the rigidity measures the angles. So it's the frame. So there is no precession happening. Some people will say that precession comes and then you measure angular momentum. No, it's not the precession. The gyro is maintaining its rigidity, but the frame is attached to the aircraft of the gimbal system. And the frame moves as the aircraft moves. Same, simple. The frame copies the aircraft. And the rigidity will show me a different reading. It will show me this reading when the aircraft is rolling. When the rolling to the left, it will show me left reading. Simple. Does it mean the gyro doesn't have rigidity? No, it has rigidity. Without rigidity, it will malfunction. So how am I getting this angular measurements? It is because the frame is moving with the aircraft, and the single axis or dual axis, single gimbal or double gimbal is designed in such a way that when the aircraft goes away from the straight and level attitude, we see the actual angular measurements on the instrument. It is tuned in such a way. The designers have made it in such a way. Okay. So number 3, what is the third angular measurement you will write down? Heading change. So how do you figure out heading change, students? Very simple again. You take your north, magnetic north, half diamond. Okay. And let's say the aircraft is changing from magnetic north to this heading. So this is your theta. Here approximately we have 45 degrees heading change over here from magnetic north. 0.45 degrees heading change from magnetic north in this example. We can say in this example, old heading 000 M, heading change from old heading 0.45. Simple. This is also measured by gyro, known as gyro compass or DGI, directional gyro indicator. So this directional gyro has a magnetic compass influence on it. And it maintains its rigidity in such a way that it aligns with the magnetic north and shows us all the directions with respect to magnetic north instantaneously without any errors. There are certain errors in a magnetic compass known as turning errors and acceleration errors. So displacement gyros are gyros that measure angles. Okay. And what kind of angles? Pitch angle, bank angle, and heading related angles. That's point number 1 in displacement gyros. That it measures angles. Okay. We will write point number 2 for displacement gyros, that all displacement gyros will have how many degrees of freedom, or how many gimbal systems. That is the point of concern for us. Okay. But before I give this to you, why not let's write about rate gyro. Point number 1 for rate gyro. Rate gyros measure angular rate, that is rate of change of angles. Measures angular rate, that is rate of change of angles. If I have to measure angles, I'll get displacement gyros. But if I want to measure the rate of angular change. Now you might be wondering, sir, what rate? What is this rate? So I'll tell you, in aviation, you have standard turns, rate 1, rate 2. Okay. Those turns tell you whether you will complete a turn in 1 minute or whether you'll complete a turn in 2 minutes, whether you'll complete it in 3 minutes or whether you'll complete it in 4 minutes. So let me tell you, okay, if you are moving 3 degrees, okay, if you are moving 3 degrees every second, okay, 3 degrees 1 second, then how many degrees will you be able to move in 1 minute? 3 degrees in 1 second. Then how many degrees in 1 minute? Nandini, Mohammad Azam, put your answers in the chat box. Always mention your unit also, okay? In your answers. Mohammad Azam and Subhajit, good, correct. Nukul and Nandini, Nandini, correct. Nukul,
15, sorry.
think about it. 3 degrees 1 second. So in 60 seconds, Nukul answer. Always use your calcies. Come on, Nukul, fast. Nukul, give me a verbal answer. It's okay. What are you writing? Nukul, it's okay if you give me a verbal answer. Don't be shy.
Sorry, sir, it's not working properly. Answer is 20.
How 20? 3 degrees in 1 second. So in 1 minute, how
Sorry,
many
sir.
degrees? 3 degrees in 1 second. So in 1 minute, how many degrees?
180.
180, correct. So it means if you turn 3 degrees per second, then it will take you 1 minute to complete a 180-degree turn. That is U-turn. And if you want to complete a whole circle, then you need how much? Double the time. That is 2 minutes. Okay. Remember this, students. I'll give it to you after this in the end. Okay. Measure angular rate, rate of change of angles. What is it? What is it? Okay. Let's assume we have a magnetic north. Okay. And let's say that the pilot's original direction is this. Original heading. While this is new heading. You need to establish this heading. New heading. So in how much time will you establish this heading? That can be found out. How much is the theta here? The theta is 45 degrees. If you use rate 1 turn, rate 1 turn will mean 3 degrees per second. And rate 2 turn uses 6 degrees per second. So generally a pilot or you will be turning by having a controlled turn. That will be a turn which will be rate 1 turn. Every second, 3 degrees. So how many seconds will you cross 45 degrees from original heading to new heading or required heading? 45 divided by 3. How many seconds? Who can tell me?
15.
15 seconds. So it'll take me 15 seconds to shift my heading by 45 degrees if I'm doing a rate 1 turn. And your turn coordinators show you rate 1, rate 2. Simple. They show you only two headings. So if you roll the aircraft, and how do you turn? How do you turn, students? By rolling or banking, but not by yawing. Okay, remember that. Yawing will automatically happen when you roll. Roll causes yaw. Remember that. Aerodynamics. If you try to roll or change the heading of the aircraft only by yawing, the aircraft is not designed to do 45-degree change in 15 seconds just by yawing. It's not possible because the load taken by this vertical stabilizer is only limited up to a few degrees. You can only move the rudder only up to a few degrees. Okay, you cannot move the rudder up to a higher degree. Only a few degrees, less than 20 degrees, I would say. A rudder is not allowed more than 20. It's much more lesser than 20 degrees. About 8 degrees to 10 degrees is the maximum moment. So here, your aircraft has to turn at a rate that is 3 degrees per second. That is 180 degrees per minute. How do you measure and how do you know whether your turn is measured? How do you know whether you're not slipping or skidding? Your gyro will show it to you. Simple as that. So you need to maintain your turn, and which gyro will make sure this is happening. I'll show you, but they are rate gyros. Remember the first classification, rate gyros. So your aircraft has to come on the new heading from the old heading like this, old to new. So 15 seconds time taken. (180° per minute). And this one, 6 degrees per second will give me 360 degrees per minute. So rate 1 turn, you make a full circle 360 degrees in 2 minutes. Remember this much. And rate 2 turn, 180 degrees you do in 30 seconds. Nukul, writing it down? Rate 1, rate 2. Nandini, Mohammad Azam, Subhajit following. So now we know what displacement gyros measure, what rate gyros measure. What are there are two different types of gyros. Now we talk about the gimbal system. How many gimbals are there? One gimbal at least will be there in all gyros. One rotor. One rotor is always there. So if I talk about the gimbal system of a gyro, what does it look like? If this is a rotor, this is the spin axis. So there will be a shaft. Along the shaft, there will be one gimbal over here. And then there will be like this. And then there can be another gimbal. So this becomes 2 gimbal system. And then it will be attached to the frame. This becomes frame like this. So some gyros will only have one gimbal like this, and then the frame. Some gyros will have two gimbals and then the frame. That's it. Those are the two types of gyros that you have in aviation, in your aircraft. Single gimbal and double gimbal. That's it. The third one is always frame. Okay. So let's write down what type of gyros or gyros are displacement gyros. Okay. Number 2. First, we studied or we understood the two types of gyros as to what it measures. Now we are talking about the gimbal system. So number 2, write down gimbals. You write 2 gimbals. With 2 degrees of freedom. And the same for a rate gyro, gimbals, you will write, rate gyro has one gimbal only with 1 degree of freedom. Right now, I want your focus to be on the theory more than the visualization, okay? Otherwise, the classification is very difficult to understand. So rate gyros, 1 gimbal only. Displacement gyros, 2 gimbals. Rate gyros, only 1 degree of freedom. Displacement gyros, 2 degrees of freedom. What is this freedom? It is allowing the rigidity axis of spin to be fixed in one direction and then allowing the other gimbals to freely rotate so that we can get the measurement. So if an attitude indicator is giving me 2 measurements, like the pitch up, pitch down, and roll, so I need 2 degrees of freedom. If my turn or turn coordinator is only measuring the rate of turn, then it only needs 1 degree of freedom. That's the ultimate application. Okay, there's nothing else. It's only this much. Okay, let's write down the third point of consideration, examples. What are the examples? So this is like studying in a reverse way. It just has one angular measurement, that is it only. Just trying to make sure the color coding is right. Now, what do you think are the examples? Simple, one of the 4 instruments or 3 instruments that we have seen. Write down number 1, directional gyro indicator, DGI. Number 2, write down artificial horizon, or also known as attitude indicator. Okay. Here you put an asterisk and write down artificial horizon is a tide gyro. That is earth gyro. Like this. And third is, that's it, DGI and artificial horizon. There is no third displacement gyro that we have. Rate gyros, write down rate of turn indicator. There are different terms given to the same instrument, rate of turn indicator. There is one more application beyond your scope, but good to understand is yaw dampers. So your thinking is correct. Your thinking is correct sometimes, like when you said earlier that's a yaw angular measurement. Yes, directional heading related. And then yaw dampers. What are yaw dampers? You can look up in your free time. Dampers are anything that create balance. Yaw dampers are a part of your autopilot. Okay. So it's an added information. Rate of turn indicator is of utmost priority. What are the top three that we need to study? Top three is DGI, artificial horizon, and rate of turn indicator. Slip and skid indicator is situated with the rate of turn indicator only. Take a minute, go through this quickly, study it nicely, see if you have any questions. Describing gyros, there are two types of gyros. One, those measure angles, others, those who measure the angular rate of change. The ones who measure angles are known as displacement gyros. The types of them are DGI. DGI measures heading, and artificial horizon, it will measure roll or bank angle along with pitch up or pitch down angle. Rate gyros will measure the rate of turn, rate 1 turn or rate 2 turn. 3 degrees per second, 6 degrees per second. Turn and bank indicator. Simple classification. Rate gyros are very simple to understand. The complication comes in displacement gyros. So I'm going to write down displacement gyros further subdivided into now there are types of displacement gyros. Okay. One is called space gyro, and the other is called tide gyro, or space gyros and tide gyros. So the first classification is displacement and rate, and then the displacement is further subdivided into two, that is space gyro and tide gyros. All right, students. Now let's write down the peculiar points or important points about all these space gyros and tide gyros so that you understand what is the meaning of space gyro. As I said, just going with the notes, you will understand everything, okay, within the scope. So let's write down point number 1, space gyro. I'll dictate it. Gyroscopic inertia. So what is gyroscopic inertia? Who can tell me? What is gyroscopic inertia?
Rigidity.
Rigidity. Subhojit, you are aware? Mohammad Azam and Nandini, are you aware what is gyroscopic inertia?
Yes, sir.
Good. Very good. Write down, everyone. Gyroscopic inertia with reference to a point in space. Now it could be any point. It could be a distant star also, as we call it. So you will see the axis of rotation of these gyros will be pointing towards not anything on Earth, but something in space, one particular point in space. Okay. Whereas tight gyro, write down point number 1, in tight gyro, gyroscopic inertia, that is rigidity only, right? So gyroscopic inertia is maintained in any particular attitude or direction particular attitude or direction. So see, attitude covers up artificial horizon and direction covers up your DGI. So here itself, you can analyze that probably both DGI and AH are type of tight gyros. Tight gyros are displacement gyros, like that. Are we following, students? So let's write down, is maintained in any particular attitude or direction of choice instead of a point in space. So here again, I'll reiterate on the point. We are trying to make sure the axis of rotation points in one direction. That's rigidity. What is that direction? For space gyro, it could be any point in space. For tight gyros, it could be any direction or attitude of our choice instead of a point in space. Okay, write down point number 2 for space gyros. Space gyros are free to wander. Now, wander is the error. Okay, the axis of rotation changing its rigidity, that is wander. So space gyros are not controlled. If they are wandering, they will wander. What do we mean by this control? What kind of control? Probably we can have a spring mechanism that prevents the gyro from wandering. If it goes away from its rigid direction, we can have a spring to bring it back. But space gyros are allowed to wander in case they are wandering. We will talk about what is wander in detail as we proceed ahead. Okay. Write down point number 2 for tight gyros. If they wander, now remember, wander is just like drift, okay? Or track error angle, you could say. If they wander, they are restored back to original orientation by an external force. So here you can write under space gyros, free to wander, no mechanism to restore. Simple. Write down point number 3. Now, when we talk about wander as an error, there will be types of wander. Okay. So write down what I'm giving you. Real wander should be low and negligible. If we need space gyros to for any appropriate function, they cannot wander. Especially real wander. What is real wander? We will see. It's just type of errors. When we talk about rate gyro, on the other hand, okay, wander is not an issue because it is restored. Okay. Before I give you the third point for rate gyro, write down the fourth point for displacement gyro. If they wander, they cannot be corrected back to their original datum or reference. That's it about space gyros. Space gyros are not very important for us. What is important for us then? Tight gyros. Okay. Write down the third point for tight gyros. In DGI, which is a tight gyro. Okay. In DGI, which is a tight gyro, if directional gyro is used, in a gyro magnetic compass, which is actually the case, okay? It is referred as tied to or slaved to. These are the words. Tied to or slaved to. Remain on the magnetic north. So tight gyros basically will be tied to the magnetic north if we are using a directional gyro for an application of gyromagnetic compass. So if the rigidity is deviating or wandering away from the magnetic north, there will be certain external force applied wherein they will bring back the rigidity to its original magnetic north direction. It could be spring type mechanism, it could be some other type of mechanism. Okay. Now point number 4 is very tricky. Tight gyros. Okay. They have a subset classification. So we know DGI is a tight gyro. We know artificial horizon is a tight gyro. Okay. I've already said attitude and heading were your indicators that they are tight gyros. But what is this subset? What is this classification? Okay. The subset is earth gyro. And what is a gyro? A gyro in which vertical or horizontal reference is maintained with respect to local gravity of Earth. Example, artificial horizon. That is your attitude indicator. Note, tide gyros can or cannot be, that is, may or may not be Earth gyros. But Earth gyro is always a tide gyro. This is a point of confusion. Subhajit, Mohammad Azam, Nandini, and Nukul. Read this classification. Sit and study this classification for a couple of minutes and tell me if you understand this classification. It really makes it easy for you to give answers to the questions in the examination if you understand this classification carefully. If you are done with it, then we'll take a break and then we will come back and study wonder. So classification or types of gyros is only this much as applicable or within the scope of our CPL studies. It's a very simplistic method of learning, a very strategic way of understanding the different types of gyros. I'll be giving you detailed pointers about all types of gyros. Okay. DGI, artificial horizon, turn and slip indicator or rate of turn indicator. In that are rate of turn indicator and slip indicator, and then turn coordinator also. So either there will be a turn coordinator or there will be a turn and slip indicator or a rate of turn indicator. One of those two instruments will only be there in your aircraft. So that will come. We'll further dwell into AH and DGI and turn and bank indicator. But today we are just working on the classification. Everyone go through the classification, sit and study and tell me if you understand it. Just read through it and see if you understand. You don't have to memorize it right now. It took me a lot of time to make it this simple. Trust me. Otherwise, when you read text, even if you read Oxford with respect to this, you'll be confused again and again. What is what is what? But when you study it this way, that's when you understand, okay, the first classification is displacement and rate. And then space and tide are a part of displacement gyro. Okay. And then tide gyro is R gyro, DGI and AH. And out of that, there is an earth gyro that is AH. So DGI is tide gyro tied to the magnetic north. AH is a tide gyro tied to the local gravity. So it becomes an earth gyro. So tide gyros may or may not be earth gyros because DGI is a tide gyro but not an earth gyro. Because it's fixed to magnetic north, not the gravity. But those gyros which are fixed to the gravity, vertical or horizontal, whatever, they are earth gyros, and earth gyros are tide gyros. Take your time. I'm not rushing you into learning it as swiftly as I have learned it. But trust me, to me also, it's taken a lot of time to get this clarity in my mind. For you, I have put it on platter on a plate. You have to just eat it and digest it and work and convert it into good energy. Food is meant to give us good energy, right? So the energy is your knowledge. You have to take this knowledge with you. I'm not only focused on your exams, also your knowledge. Mohammad Azam, any doubts? Are you understanding the classification of gyros? Nandini, are you understanding the classification of gyros?
Yes, sir.
Confusion?
No, sir.
Are you reading through it? Subhajit and Nukula reading. Mohammad Azam, you and Nandini reading through it, right?
Yes, sir.
Subhajit, any doubts? Confusion?
No, sir, nothing as of now.
Easy, right? Looks easy. It is
Yes,
easy.
sir.
Trust me, it is easy. When we write it correctly, it is easy. Nukul?
Getting sure.
Good, good. Go through it 3 minutes more, then I'll give you a break and we'll meet after the break. I hope everybody is okay after studying after the break also. Past two sessions we have wrapped up at 6:30. Today we are going to stretch a little. Let's do wonder also, so that Friday we only have to talk about specific instruments. Friday is all about just notes and just knowing this about this particular instrument. That's it. Because major explanation is given here only. You just have to remember. Remember in your notes, further reading, there are errors also which I'm not discussing in class. Those errors you have to read and add to your notes. That will be something that you have to do on your own, like gimbal lock. There is an error called gimbal lock. It is like when all gimbals align in one plane. That is gimbal lock. So gyros are two types, displacement and rate. Displacement gyros will measure angular displacement or measure angles basically, pitch angle, roll or bank angle, and heading angle, while rate gyros will measure rate of angular change. There are two rate of turns that we follow in commercial aviation, and your gyros will be designed to measure those only. If you maintain the rate, you will not slip or skid. If you don't maintain, then chances are you might slip or skid. The slip and skid indication will be given to you with the help of an inclinometer, okay, which is attached to your turn and bank indicator. All right, so let's take a break, everyone. Let's meet in 5 minutes. So everybody has done time calculations, right? So if it is 1823, then what will be the time after 15 minutes? Plus 0015. 8318. Correct. Good job, everyone. Subhajit, very quick to give it. Mohammad Azam, very quick to give it. Very nice. Nukul, क्या सोच रहे हो? सर ने क्या पूछ लिया?
Sorry, no sir, create. I give verbally.
Nandini, you didn't give the answer. I hope you remember time.
Yes, sir, I did.
Okay, let's everyone come back at 1839 hours. Okay. Welcome back, everyone. Is everyone back? You must be like, sir, आज पहली बार बड़ा break दे दिया, पता ही नहीं चला, ज़्यादा हो गया. You're not used to getting 15 minutes, right? 10 minutes only. Thank you for coming back, everyone. Let's get done this with this thing. What
Welcome
is
back,
this
everyone.
wonder? Just a second. Mute and pause. Okay. Let's talk about this thing known as wonder. What is this wonder? Okay, we wrote something called real wonder, right? And I told you there is another type of wonder. Let's write down what is wonder. A simple definition. Any deviation or displacement or departure. These three have the same meaning, okay? Any deviation, displacement, or departure of a gyro axis. Which axis we are talking about? We are talking about the spin axis that is maintaining rigidity, okay? Departure of a gyro axis from its original orientation is called wonder. Read it again. Any deviation, displacement, or departure of the gyro axis from its original orientation, the rigid orientation, okay? The gyroscopic inertia orientation. If a gyro is displaced or the axis is displaced, we say it is a wonder. Okay. Now, there are two types of classifications. First, I'm going to classify wonder in two types, drift and topple. Okay. And afterwards, we will come back to wonder and then we'll talk about real wonder and apparent wonder. Okay. So now you make this classification for wonder in two types. Wonder. Okay. Number one is drift on the left side. And on the right side, you will write topple. You already know what is drift and topple, but this classification is important because drift and topple are also types of wonder only. Okay. Write down point number one about drift. What is drift? When gyro axis wanders in the horizontal plane, it is called drift. And write down about topple. When gyro axis wanders in the vertical plane, it is called topple. Write down point number two for drift. Horizontal axis gyros can drift and topple. Drift will be a deviation in the horizontal axis, and topple will be the horizontal axis coming into the vertical axis or vertical plane, horizontal axis gyros. Whereas vertical axis gyros can only topple. Remember this point. Now, this drift can be real or it can be apparent. And this topple can be real or apparent. Okay, both. So drift can be real and apparent. Topple can be real and apparent. Both. Why? Because drift is also wander. Topple is also wander. What is wander? Deviation in the axis of the gyro axis from its original orientation. What are the reasons why it will deviate, students? We all know it is precession. It will be precession. Real, apparent, real, apparent. So your topple could be real or apparent. Your drift could be real or apparent. Right? So same. Real or apparent, real or apparent. Together, they are nothing but wander. And now I'm going to show you how wander is divided in two parts. That is real wander, and it's very simple to understand, okay? And apparent wander. Any confusion? So your drift could be real drift or apparent drift. Your topple could be real topple or apparent topple. Got it? They all mean wander only. So real wander, real drift, real topple, same meaning. Apparent wander, apparent drift, apparent topple, same meaning. It's just that the plane of deviation is different. Got it, everyone? Should I go ahead? Any doubts? If you don't ask doubts, it means I'll go ahead. Simple. Subhajit, good to go? Just little bit left. Just little bit left. You'll be surprised to see how easy it is. Write down real wander. A few points for real wander, a few points for apparent wander, and then we are done. Write down point number 1 for real wander. Axis of gyro moves with respect to inertial space. Point number 2, such a deviation is caused by manufacturing defects or imperfections. Example of real wander: rotor bearings. Now, students, everything that rotates or revolves in aviation, a mechanism, will have bearings to reduce friction. Even your bicycle wheels have basic two bearings at the axle. Okay. Everything that rotates to avoid friction, we have ball bearings. What are bearings? Bearings have a metal disc outside, metal disc inside, and in between you have metal balls. We call them ball bearings, like this. So it avoids friction between the two moving parts. One will be inside here, moving part, and one will be outside. So that are ball bearings, okay? There are different types of bearings. The most common are ball bearings. So any bearing attached to the rotor, okay? So rotor bearings being uneven. If the bearings are not even, it will cause real wander, okay? Example 2, rotor mass imbalance. If the mass of the rotor is not concentrated properly along the rim in a symmetrical nature, then it will cause real wander, okay? Number 3, gimbals, one ring or two ring, inner gimbal, outer gimbal. The gimbals being out of balance. So this is real wander. Write down point number 3. Real wander is also called as apparent wander. Correction, random wander. I say again, real wander is also called as random wander. Do not get confused, okay? I did an error in speaking. It should not happen. Random wander. So if there are manufacturing defects, if the gyro is not constructed properly, or let's say after a few hours of service, it wears off, okay, there's wear and tear and it goes out of balance, or the bearings are not working properly, or the gimbal friction is high, okay? Rotor bearings, rotor mass imbalance, gimbals being out of balance, or you can write gimbals having high friction. Point number 3, don't write gimbals out of balance. Change it and write down gimbals having high friction. Imbalances with rotor mass, gimbals having high friction. So these points are basic points, but questions are asked on these points. Mark the correct statement, or with respect to real wander. Real wander happens because of this, 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 this. So you won't have to guess in the exam. You know what are the reasons. Manufacturing defects or imperfections. Inertial space. And what is the other point? That's it. Moves with respect to inertial space. You can put an asterisk if you're confused what is inertial space. But remember the keywords. Now, what is more important for you as a pilot is the apparent wander. Now, students, if you remember, variation, the difference between true north and magnetic north, it changes from the observer's physical position. True or false? If let's say Subhojit is at one point from where Subhojit sees true north is straight and variation is 7 degrees east, for him it is easy to guess. But what if Nukul is on other part of the earth? Let's say 1/4 of the earth on the equator. So what will be the variation for Nukul? For Nukul, that is the true north. The local meridian is always the true north, students. If you remember, your local meridian is always the true north. So what will be the variation for Nukul? For Nukul, the variation might be different. Do you remember this? Mohammad Azam, Nandini, Nukul, Subhojit is nodding yes. Nandini, Mohammad Azam, Nukul, no response. I'm talking about variation.
Affirm, sir.
Mohammed Azam, are you there? No response. Victor Tango Alpha Mike Alpha. See, students, I'll just show you what I was talking about. If this is the Earth, okay, let's say this is the true local meridian, true north for Subhojit over here, S. And for Subhojit, let's say the variation is 7 degrees east. So magnetic north is somewhere here. Okay, 7 degrees east. So what about Nukul? If Nukul is somewhere here. For Nukul, the local meridian true north will be this, and the variation will be something else altogether. Probably for Nukul, the variation will not be because they both are in line with each other, coincident. So there will be zero variation for Nukul. For let's say Muhammad Azam is sitting here. For him also zero variation because they both are in the same line. But let's say Nandini is here. So for Nandini, this is true north. So where is magnetic north? The value will change. Variation. It changes with respect to the observer's location. Apparent wander is all about that. When you are using a directional gyro, okay, or let's say you are using any gyro wherein it is a tied gyro and it is tied to the local meridian, that is your true north. Although DGI is reference to magnetic north, there are other gyros which are part of your inertial navigation system, okay, wherein they will be aligned with the true north, which is your local meridian. So when Subhojit is traveling from his local meridian to say another destination meridian, let's say Nukul's meridian. So the observer's frame of reference is going to change and there will be visible errors. Those are known as apparent wanders. Apparent. They appear to be an error because of your change of position. So what happens is, so if Subhojit is on this position, so the gyro will align with the true north. Let's say it's a tight gyro to align with true north. When Subhojit reaches this point, Nukul's point, that is destination, the gyro will still be aligned with this north. While the gyro should not have been aligned with this north, it should have been aligned with its local north. Let's say for Nandini, if Subhojit flies in this direction, this position where November, this Nandini is there, still the gyro will be aligned with this north. But Nandini should be having a gyro aligned with this north in the destination to get accurate reading. Like this. So there is a difference between your departure alignment and your arrival alignment. That is known as apparent wander. So the gyro will remain fixed to your local meridian only. And if you change your meridian, the gyro will not come to that meridian. So there is a deviation for you because you needed a local north reference, but you are not getting that local north reference. Subhojit, stand by. I will check. Are you using a computer, Subhojit? If you have a soft copy, then
Yes,
I'll ask you to share your screen.
Okay, sir. I'm just getting the copy in my folder.
Yeah, get onto it. Let me know when you're ready. So students, Subhajit in between also make notes. Continue writing. So let's write down apparent wander first. I think that 47 image you're talking about variation. Difference in variation, is it? Subhajit?
Yes, sir. Difference
Yeah,
in
the picture
variation
makes
of
it
two
very easier
observations.
to understand. Yes, correct. Do you want me to explain that image or something, or do you want me to just share it with class so that they understand better?
Sir, only share it with the class. I have understood that.
Very good, very good. Good, good, good. We will check that at the end when we exit, before that, okay? So write down about apparent wander. Point number 1 about apparent wander. with all real wonder removed. Let's say that we have removed for all the manufacturing imperfections and we have made sure that the gyro doesn't have any real wonder. Okay. With all real wonder removed, the gyro will point at a distant star and will maintain that orientation. Correct? This is rigidity, space gyro, and will maintain that orientation. Full stop. There are chances that the direction indicated by gyro is different than the original. So remember, students, this apparent wonder is always with reference to the original, that is your point of origin, that is departure, and then your arrival point. Always. The original, if you're wondering what is the original, it is that at your departure point. Okay. Point number 2. The difference is due to the observer's frame of reference. Due to the observer's frame of reference changing over a course of flight. Now we talk about what are the causes that the observer's frame of reference can change due to. There are 2 reasons why your observer's frame of reference can change. Who can tell me? One is definitely when I'm traveling from one point to another, like I explained, from one meridian to another meridian. Definitely. Okay. Another, what do you think could be a reason that an observer's frame of reference could change? Just make a wild guess quickly. Nandini, you got it right. The Earth's rotation. The Earth is not stationary, although our gyro axis is stationary. With respect to the Earth below the gyro, the position will change because of Earth's rotation. Very nice. Good guess, Nandini. Well done. Very happy. So observers' frame of reference can change due to 2 reasons. Mohammad Azam, please acknowledge. I'm not sure if you're there in class. Yeah, he's there. Good. Number 1, rotation of Earth. And number 2, flying east or west on latitudes other than equator. Remember, okay, these simple sentences have a lot of important data with respect to critical questions often asked. So your apparent wonder will only happen on latitudes other than equator. It will not happen on equator. When you are considering the change of frame of observer's reference, flying east or west, easterly or westerly, either you'll fly easterly or westerly, right? Only two possibilities. Either you'll fly easterly direction or westerly direction. Sometimes northeasternly or northeasternly, northwesternly, but westerly or easterly can be one of the two directions always. So rotation of the earth and flying east or west, whenever you are flying on at latitudes other than equator, you will experience apparent wander. And there is a definite apparent wander that you can experience due to the rotation of the earth. Okay, now write down the key points. Rotation of the earth. I'll take it here. Apparent wander due to Earth's rotation is called as Earth rate. So do not confuse if you come across words like Earth rate. Earth rate is simply apparent wander due to Earth's rotation. Okay. Write down the following points. If you have to calculate Earth rate, then it is possible. Earth rate is equal to 15 into sine lat per hour. Now, can anyone tell me why 15? Forget the sine lat. I don't want you to explain me any trigonometric functions. I want you to just remember the formulas. But who can tell me 15? What's the importance of 15 over here? What do you know about Earth's rotation? How much time does it take to rotate once? 360 degrees. Nukul?
4 hours.
24 hours.
24 hours. So how many degrees in 1 hour?
15 degrees. Sir.
15 degrees in 1 hour. Simple. Very simple. That's why 15 degrees per hour. And why sine lat? Because it's a trigonometric function due to convergency. That's it. Nothing else. Because your latitudes converge. That's why sine lat. You don't need to prove that. It's beyond your CPL scope. But 15 is within your CPL scope. So don't be surprised if you get any numerical. It's a very easy, students. You will be having your scientific calci. All you need to know is the formula for Earth rate. That's it. They will give you a latitude. Maybe they will give you a complicated question where you have to reach the latitude. They will give you a D long or something, right? They'll give you, you find out your destination latitude, then use that in the formula. Whatever you get will be your Earth rate. So point number 1. And point number 2 about Earth rate, which is actually apparent wander due to Earth's rotation. Point number 2, it can be positive or negative. Okay. Earth rate can be positive or negative based on northern hemisphere and southern hemisphere. If you're traveling in the northern hemisphere, the Earth rate will be either positive or negative. If you're traveling in the southern hemisphere, then the Earth rate will be either positive or negative. Okay. So write down point number 3. Earth rate is negative in northern hemisphere. And point number 4, ER, I'm writing short form for Earth rate. Earth rate is positive in southern hemisphere. In your Oxford textbooks, explanation is given. I would suggest you all read it once you're done everything. Complete study before your exams. Only after that you read it. for extra information. Nobody's going to ask you how, but it really explains. But the language is very complicated. Try to read it twice or thrice to understand. Okay. Y negative, Y positive, just trigonometric functions. Okay. That is earth rate. Now, what about the second one? What about flying east or west? What about flying east or west? What is it called? Write down. Apparent wander due to aircraft flying east or west. In bracket, write not on equator, specify, okay, is called transport wander. So it's just a name given. What type of wander is it? It's an apparent wander. Apparent wander because of flying east or west other than on equator is known as transport wander. An apparent wander due to rotation of the earth is known as earth rate. What is wander? Any deviation or displacement in the original orientation of the axis of the gyro. Are we following, students? You should not be tricked by new words called transport wander and earth rate. These are just words and specific terms given to gyroscopic instrumentations. They are just angular deviations, something that you have done in general navigation, in-flight navigation, 1/60 rule, drift, and so on. Write point number 1 for transport wander. There's just 1 point you have to write. Happens due to the difference in the alignment. Okay, difference in the alignment happens due to the difference in the alignment between the meridians of departure and arrival locations. Note, consider spin axis was aligned with the meridian of place of departure. So this much of note should be good enough for you to understand what is wander. Whenever your gyro is tied to the local meridian, you will experience transport wander when you're traveling. Okay. If it is aligned with the magnetic north, then it's not an issue to us. But if it's aligned with your true meridian or your local meridian, that is your true north, only then we will be experiencing this issue. So transport wander and earth rate are types of two apparent wanders, while real wander is inherent, which is actually reduced by the manufacturer itself. Wander is any displacement of the rigidity of the axis of the spin axis of the rotor. Take a minute, go through wander Drift and topple are wanders, horizontal and vertical planes. Could be real apparent, could be real apparent. So horizontal axis gyros can topple also, can drift also. The topple and drift could be real, could be apparent. If the manufacturer has done a good job, then the real drift or real topple will not be there. Only apparent drift and apparent topple can be there wherever applicable. DGI tied to magnetic north. Artificial horizon tied to a gyro. Two gimbals, one in vertical plane, one in horizontal plane, like that. Yeah, Subhajit, go ahead.
Sir, can you scroll up? I missed out of writing a point.
Where? Let me know where to stop.
Yes, sir, here only.
Okay.
Yes, sir, done.
Students, go through the notes, see if you understand the classification. This is basic classification. The last part of gyro that we'll be covering on the weekend, not weekend, Friday, would be specific notes about all these different types of gyros. DGI, AH, turn coordinator, turn and slip indicator. Remember, turn coordinator is more advanced than the turn and slip indicator. We'll talk about it. So even on Friday, we might need extra time like today, but we'll cover it. Nandini, I understand you'll not be able to attend on this Friday. Is that right?
No, sir, I can.
You cannot, right?
I can attend.
You can? Very good, very good. Amazing. Good job. So great. So remember this much. I would want you to at least be very thorough up to this point. Okay. It has a lot of key points. So you have to remember this description as it is. Okay. Try to understand as it is, and then you convert it into your own language or own words if you want to. But this is the most easiest classification you'll come across in simple words covering all key points. Okay. Mohammad Azam, any questions?
Negative.
Nukul, questions?
Negative, sir.
Subhajit?
No questions, sir.
And Nandini, any questions?
No, sir.
Okay. Go through your notes. I'll share the picture with y'all, the picture that Subhajit is sharing. But Subhajit, I don't think I can open this file.
Okay, sir, then grant me access. I will share the screen.
Wait, just a second. Let me see. Would not. Okay. Okay. Open with. Just a second. Students, just keep looking at your notes. See, give yourself 2 more minutes if you have any questions. It's not like I'm trying to kill time or something. Open with. Paint. Got it. Yeah. Students, I'm sharing my screen. If you come across any personal sensitive data, just ignore it. Okay. Yeah, fine. So this is what we were talking about with respect to variation. Okay. Look here. You can see the cursor, right, everyone? This point. This is true pole or true north pole. Okay. This is magnetic north correction. This A is variation. This is magnetic north pole over here. Wait, let me erase it. Control C. And this here, which I'm circling, is magnetic north pole. If a person is on this true meridian, okay. So for this person, the variation is the angular difference between true north and magnetic north. And this looks like a westerly variation because magnetic north pole with respect to my prime meridian, it is on the west. All right, students. Follow my instructions. Okay, so this and this westerly variation, right? With respect to point on this meridian, 0, 0, east, west. See, it's written down. For this person, it's a westerly variation. But they're talking about what are the chances when your variation will be 0. So although there is a difference, though this circle is 85° north latitude parallel of latitude, 80° north, 75° north, a person on this meridian will see magnetic north pole and true north pole in the same line. So for this person, there will be no variation. But for person on prime meridian, there will be a westerly variation. A person on the anti-prime meridian, it might be an easterly variation. But a person on this particular meridian, yellow meridian, no matter where, will have 0 variation at the same time. Why? Because true north pole and magnetic north pole is in the same line. But if the pilot or the aircraft along with the pilot is in between true pole and magnetic north pole, this position A, then the maximum variation will be 180 degrees because true north is exactly behind you and magnetic north is in front of you. So if you're going in this red direction, then you're going to the magnetic north, true north is behind you, 180-degree variation. And if you're taking this green path, so your true direction is front of you, magnetic is behind, again 180 degree. So if you are between the two poles, then your variation will be 180 degrees. If you are on the meridian, which is in line with the two poles, your variation will be 0. Everywhere else, with respect to the observer frame of reference, the variation value can change. Okay, remember this much. Mohammad Azam, have you covered this topic in live class? Variation?
Variations, I'm not sure, sir. I don't remember. I need to see.
No problem. Nukul, do you remember? Have you attended?
Yes, sir.
Nandini, do you
lecture.
remember?
Yes, sir.
Good. Mohammad Azam, don't worry. Try to go through your notes and recollect whenever you're doing revision. And start your thorough revision for navigation in case you're planning to give the exam. In case, let's assume your computer number comes. Okay? So start thorough revision and let me know your points where you are weak or you need more preparation from my point of my side.
So we need to work on that notes also.
On notes, yes. Yes. Yeah. Remind me today, message me. I'll tell you. I'll send you all notes. We have all notes, but it's very time consuming, nothing else. Okay, but I'll make sure I gather them. I'll gather them in sequence, 10 now, 10 then, 10 then, so we can get it done within 2 days. All right. Subhajit, thank you very much for sharing, very resourceful. And if you have any doubts, students, you'll ask me on Friday.
So it's
Do
from
revise.
Oxford book. Sorry.
Yeah, it's in Oxford.
Yes. So I
Direction.
revised book, but I didn't understand the whole diagram.
Oh, you should tell me, students, whenever you're revising, whatever you don't understand, either click a picture or write the page number in your parking lot or make sure you discuss with me. Okay? Remember this, okay? From now on.
Okay.
Don't take the burden of not knowing something or being confused. Put it on me. I'll make sure I explain it to you again and again and again. नुकुल, अगर ऐसा हुआ है तो लिख के रखना और तभी का तभी मुझसे शेयर करना है या फिर पार्किंग लॉट में लिख के रखना है डेट ऑफ रिवीजन एंड द डाउट. ये मिस नहीं करना है हमें एग्जाम्स के लिए, है ना? I'll teach you again. I don't mind teaching again, students. Mohammad Azam, don't worry. Okay? There's a lot to study. होता है, कुछ चीजें भूल जाते हैं हम लोग, होता है, उसमें क्या है? We'll revise, we'll study. I'll explain again, don't worry. Okay?
So just now I understood what it's for, the topic which you showed. I understood that, but I'm recalling whether I studied this topic or not.
Fine. Recall, let me know. And Nukul, तब जब नहीं समझा था रिवीजन में, again if you come across any such revision or still if this point is not clear, put it in the parking lot and share with me. I'll teach again, okay? It's my job to teach again. अब जब हमारे पास टाइम है तब अच्छे से पढ़ सकते हैं हम लोग, नहीं तो पता है ना सुभजीत, यू रिमेम्बर द प्रेशर ऑफ एग्जाम्स राइट? नहीं होती अच्छे से पढ़ाई, कितना भी सोच लो अच्छे से नहीं होती है. All right, so I'll see you all Friday. Let's finish gyroscopes. I'm hoping there's a lot of material for you to write down. Not lot. It's simple. It looks a lot. We'll be doing a couple of numericals also based on gyro, just in case they come in the examination. So yes, Subhajit, go ahead.
For Friday's class, I will see the recording because I won't be available. So
No
I'm going
problem.
outside.
No problem. But if you have any doubts while going through the recording, write it down and shoot it out to me afterwards. Okay. After that,
Yes.
I'll be on a leave for a week, students. So I'll not be there, but I'll guide you what to do in that much of time. All that I'll discuss on Friday with you all. Don't worry. 1 week I'll not be here, so I'll tell you all to do a thorough revision. I'll give you a strategy to follow, and you try to do that. Okay. And after that, when I come back, I'll wrap up with your radio navigation, whatever is left. Okay. Remember this much. All right. I'll take your leave. Thank you so much for being so
Sir.
nice. Yeah, Nukul.
Sir, at what time we will discuss about the computer number?
I'll give you directions as to what you need to do tonight before sleeping. I'll get back to you on that.
Okay,
I'll get back to you personally. You just drop me a message
okay, sir.
right now after class.
After 9 o'clock or 10 o'clock.
I'll drop you a text if you're not available
Okay,
on call.
sir.
Don't worry. Don't worry. We'll
Okay,
be
sir.
spontaneous.
Okay, sir.
But we'll do it today.
Okay, sir.
All right. All right. Okay. Chalo. Bye.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
everyone.